This is just a short example of a question where I'm going to need to make certain assumptions and estimations to come up with an answer. This should give you an idea of the type of estimates or assumptions that you might do in some of the take-home problems that I've given you. So the question I want to answer is, what is the kinetic energy of a bowling ball shortly after it is thrown? So I'll do a mechanics example so I don't ruin any of your fun or any question I might want to ask you about anything electricity or magnetism related. So we have a bowling ball. I'm going to assume that it's rolling as it travels down the lane. So the total kinetic energy, there will be a translational kinetic energy given by 1/2 mv squared, and a rotational kinetic energy given by 1/2 I omega squared, where I is the moment of inertia of the bowling ball, and omega is the angular velocity of the bowling ball. So I have here an equation from physics class that I know that I want to use, but I'm going to have to come up with some values for mass, velocity, moment of inertia, and rotational velocity. So bowling balls, they tend to vary anywhere from 9 pounds to 16 pounds. So I'm just going to consider a 12-pound bowling ball. That seems like a reasonable value. And that means that the mass of the bowling ball is about 6 kilograms. I know it's about half of the weight in pounds, but if I want a more accurate number, I could go to Google and type in convert 12 pounds to kilograms, and Google would give me a more accurate value. I need to come up with a speed. I'm going to estimate that it takes about 3 seconds to travel down the bowling lane. When I sort of picture what's happening in my mind, that seems like about the time that it takes the ball to travel from my hand to the pins. I can look up online the length of a bowling alley. I find that a bowling alley is about 18 meters long. So if it travels 18 meters in 3 seconds, that gives me a velocity of 6 meters per second. Next, I'm going to think about the angular velocity. Yes, the angular velocity. To do that, I need to know the size of a bowling ball. Again, this is something that I have looked up online. I look up the size of a bowling ball, and the radius is about 11 centimeters, 0.11 meters. And I know from Physics 1 that angular velocity is equal to the linear or tangential velocity v divided by the radius. So if I take 6 meters per second divided by 0.11 meters, I get 55 radians per second as the angular velocity. And finally, I need to come up with a value for the moment of inertia. I'm going to assume that the ball is a solid sphere. So I'm going to ignore the fact that there are some finger holes drilled into the ball, and I'm going to ignore that in the very middle of the ball there might be a different material or anything like that. I'm just going to assume the ball is a big solid sphere. In that case, the moment of inertia for a solid sphere is 2/5 mass times radius squared. I already figured out the mass and the radius of my ball, and so I get a moment of inertia that is 0.03 kilograms times meters squared. Now, everything that I've just circled here, these are the estimates or assumptions that I've made. So I had to come up with a reasonable mass for the bowling ball. So I started with a weight of 12 pounds, turned that into a mass of 6 kilograms. I estimated 3 seconds to travel down the lane, and I assumed that I can treat the ball as a solid sphere. So in each case, I'm using a well-defined physics quantity, velocity, angular velocity, moment of inertia, things that appear in an equation that I know from physics class, but I need to figure out how to represent a ball. What is its speed? What is its mass? What shape should I use to find the moment of inertia? These are the things you have to do as you're going through the problem, and you have to point out to me when you're solving the problem that these are estimates or things that you are assuming that you can do. So now that I have values for mass, velocity, moment of inertia, and angular velocity, I can plug in all my numbers into my equation for total kinetic energy, and I get a kinetic energy of the bowling ball of about 153 joules. So there is my answer, and hopefully this will help you get an idea of how you might estimate some values, how you might look up some values on the internet if you have a problem you're trying to solve yourself where you don't know all of the quantities that you need to know.